Ever get the feeling that just looking at something, like really observing it, might actually be changing it?
You mean like when you're trying to find something and it's right in front of you, but you don't see it?
Well, no,
Yeah.
I was thinking more along the lines of, well, we'll get to that. That's kind of what
Mm.
we're going to deep dive into today.
Okay, got it, got it.
So imagine a world where just by observing something, we actually affect how it behaves. That's kind of the crazy world that quantum physics opens up, and that's exactly what this experiment, the double-slit experiment, kind of shows us.
Yeah, yeah, the double-slit experiment it's like a classic, it's like the gateway drug to quantum weirdness.
Yeah, exactly. Like it starts out pretty simple, and then it just gets stranger and stranger.
Yeah.
So to start, we're going to like set the stage. Way back in 1801, there was this physicist, Thomas Young, and he did this experiment where he took a beam of light and he shone it through two tiny slits.
Yeah.
And now, if you think about it, you would think you would just see two bright lines on the screen behind the slits, right?
Right, yeah, just two lines of light.
But instead, he got this pattern of bright and dark bands.
Yeah, like an interference pattern, right? Like when you drop two pebbles in a pond and the ripples, they kind of overlap and create these like...
Exactly.
Yeah,
Exactly.
yeah.
And so that was actually proof that light behaves like a wave.
Exactly, and that was kind of the understanding for a while, like, okay, light's a wave, we get it.
But then things get weirder.
It always gets weirder.
It always gets weirder,
With
right?
quantum physics, yeah.
So imagine now you take that same setup with the two slits, but instead of shooting a beam of light, you shoot single particles, like tiny little bits of matter, electrons, one at a time.
Okay.
Now, you would think they would go through one slit or the other.
Right. Sense, right? Like tiny little bullets?
Yeah, like tiny little bullets,
Yeah.
creating just two distinct marks on the screen.
You would think so, yeah.
But that's not what happens.
Nope.
Even when you fire these electrons one by one,
Mm-hmm.
you still get that interference pattern.
Crazy, right?
It's like each electron is somehow going through both slits at the same time.
It's as if, yeah, like it's somehow in two places at once.
Yeah, that seems impossible.
Well, welcome to the quantum world.
So is this electron really in two places at once?
So this is where we get into this mind-bending concept called wave-particle duality.
Okay.
And it's this idea that these tiny particles, they don't always act like little, like you said, little bullets.
Yeah.
Sometimes they act like waves spread out over space. It's kind of like, imagine you have like a map with all the possible routes from your house to work.
Okay.
Now, until you pick one and you actually drive it, you're technically on all of those routes simultaneously.
Oh.
And that's kind of what's happening with these particles before we measure them.
So they exist in this like blurry state of possibilities?
Exactly. And in physics, we call this a superposition of states.
Okay, superposition.
Yeah, it's like all the possible outcomes are kind of like smushed together until we look.
So what happens when we do look? When we observe which slit the electron goes through?
That's the really weird part, right? As soon as we try to measure it to see which slit it went through, the interference pattern, poof, it vanishes.
So we no longer see the wave-like behavior?
Nope. It's like they knew we were watching and they decided, okay, now we're going to act like particles again. And you just see those two distinct clumps, just like if they were, normal little balls.
So the particles are changing their behavior because we're watching. That's wild.
Yeah, it's called the observer effect, and it's probably one of the biggest head scratchers in all of quantum mechanics.
Okay. I think I'm starting to get a little bit of a headache.
Yeah, it's a lot to take in.
Yeah, but it's so fascinating.
It is. It is.
Okay, so we've been talking a lot about these electrons and slits.
Right.
But let's bring it back down to Earth for a second.
Okay.
Why should anyone listening care about this?
Well, for one, this isn't just some like theoretical idea, physicists messing around in a lab. This quantum weirdness, it's the foundation for some really groundbreaking technology.
Okay, like what?
Well, take quantum computers, for example.
Great.
They use these principles, these bizarre principles like superposition and something called entanglement, which we can maybe dive into another time.
Yeah, save that for another time.
Yeah, it's a whole other can of worms.
Okay, but so quantum computers.
Yeah, they use these principles to make calculations in ways that normal computers just can't.
So understanding how a single particle can be in multiple states at once is the key to unlocking this amazing computing power.
Exactly. And then there's also things like quantum cryptography,
Okay.
which uses these principles to create like theoretically unbreakable codes.
Wow.
It's like having a lock that, like, if you even try to pick it, it changes the tumblers.
Oh, wow.
You can't crack it.
Okay, so huge implications for technology, and it sounds like there's even more than that.
Right.
This experiment raises some pretty huge philosophical questions as well, doesn't it? I mean, if the act of observing can change the behavior of these particles, what does that even mean for reality itself?
Yeah, it's a question that physicists, philosophers, they've been debating for, like, I don't know, almost 100 years now.
Yeah.
And there's really no easy answer. Like,
Yeah.
does it mean we create reality?
What does it say about free will versus determinism? I mean, those are pretty big questions.
Yeah, huge, huge.
Yeah.
Yeah, those are questions that even, like, really smart people are still arguing about.
And it gets even weirder.
Yeah.
Scientists have done this experiment not just with electrons, but with bigger and bigger particles. Like, they've even done it with molecules, these big, complicated things, and they still see the same effect.
I know, right?
Yeah.
It's like you think quantum weirdness would only apply to these tiny things, but nope, it seems to scale up.
Yeah, and then there are those delayed choice experiments.
Oh, yeah, those are really trippy.
I know, where they don't decide whether or not to observe the particle until after it's already gone through the slits.
Right, like it's already supposedly chosen a path, but then our decision later on can still affect the outcome.
It's like they can somehow sense the future or something.
It's like cause and effect get all messed up.
I know, it's so wild.
Uh,
The physicist Richard Feynman once said that this experiment, this double-slit experiment, contains the only mystery of quantum mechanics.
and he was a pretty smart guy.
Yeah, I think it's safe to say he knew what he was talking about.
He did.
So, I guess if we had to boil it all down,
Yeah.
what would you say is the big takeaway here? What have we learned from this deep dive into the double-slit experiment?
Well, I think the biggest thing is that the universe is far stranger and more mysterious than we tend to think. Our everyday intuition, the way we think things should work, it just completely breaks down at the quantum level.
Okay.
And this experiment really shows us that observation, the very act of looking at something, seems to play this fundamental role in shaping reality.
And maybe our consciousness, this ability we have to observe and experience the world, is more connected to the universe than we ever realized.
It's a pretty mind-blowing thought, isn't it?
It really is, and I have a feeling this is just the tip of the iceberg.
Oh, yeah, definitely.
This deep dive has only scratched the surface of this amazing and mysterious world of quantum physics. So, if you're intrigued, if you're curious, there's a whole universe of information out there waiting to be explored.
Absolutely. Keep digging, keep asking questions. That's what it's all about.
Exactly. Thanks for joining us on this deep dive.
My pleasure.
And until next time, keep exploring the wonders of the universe.
And keep wondering.
And keep wondering.
Yeah.
Yeah.